Every second, your body is crossed by trillions of invisible messengers. They pass through the skin, slip between atoms, and pierce the nucleus of your cells, as if the solid matter of your body were nothing more than a ghostly lattice. You feel no vibration, no sting, no impact. Yet, at the microscopic level, the quiet storm of particles never ceases. It is not a metaphorical storm, nor an imagined one, but a measurable physical downpour that defines existence on this planet. The stillness of a room, the apparent safety of a closed wall, or the silence of night are illusions. You are never untouched. When physicists first measured background radiation in the early 20th century, they were shocked by its persistence. Shield the apparatus with lead, sink it deep into the earth, bury it beneath water, and the signals did not vanish. It was as if the world itself whispered with an untraceable current. Victor Hess, in 1912, carried an electroscope aloft in a balloon and found the ionization grew stronger the higher he rose. Something from above, not below, was at work. Since then, the suspicion has grown into certainty. We live inside an ocean of particles that never rests. This ocean is layered, complex, and indifferent. Some particles rain down from distant galaxies, born in the death throes of stars. Others seep upward from the crust beneath your feet, the slow decay of uranium or thorium atoms that have been trapped in rock since Earth's beginning. Still others are fragments from the sun itself, torn from its outer layers and flung across the void in waves of solar wind. Each source leaves its own fingerprint in the ceaseless background. The human body, evolved in this storm, has no mechanism to sense it directly. Our nervous system responds to light, sound, pressure, and heat, but it is blind to these higher energy intrusions. A cosmic ray passing through the retina may trigger a flash of light, a strange spark reported by astronauts in orbit, but otherwise, the flood moves unnoticed. The illusion of safety, the sense that a house shelters you from the universe, is incomplete. The roof can stop rain, but not what falls invisibly through the atmosphere. What makes this storm uncanny is not simply its existence, but its scale. Each square centimeter of your skin is struck every second. In the span of a breath, 1,000 billion neutrinos have crossed through your chest. By the time you finish reading this sentence, radioactive decay in the ground beneath you will have released countless alpha and beta particles that scatter into the air, mixing with the oxygen you inhale. Radiation is not the exception to life. It is the background against which life unfolds. The mind rarely considers such things. Psychology is tuned to tangible dangers, predators, fire, hostile faces. Our evolutionary history selected for awareness of motion and sound, not the intangible flux of particles. As a result, most people live unaware of this hidden layer. Yet when confronted with the knowledge, the mind begins to reshape its sense of reality. Invisible danger, constant bombardment, imperceptible change. These are not abstractions, but truths measured with instruments of extraordinary sensitivity. It is no coincidence that across cultures, myths often describe unseen forces surrounding and penetrating the body. Ancient texts spoke of vital winds, of prana, chi, or pneuma flowing through flesh. Though these concepts were not radiation in the scientific sense, they reflected a human intuition that existence is never solitary. Something unseen presses on us, moves through us, inhabits us. The modern picture of particle physics replaces mystical currents with quarks, leptons, and high-energy collisions. But the unsettling awareness remains the same. Our bodies are porous to the universe. This porousness challenges the very idea of the self as a closed boundary. If particles from distant stars pass through you at this moment, Are you still separate from the cosmos that created them? The philosopher Erwin Schrödinger once remarked that the physical boundary of the body is only a temporary eddy in a stream of particles. To live is not to hold particles still, but to maintain form while matter flows through ceaselessly. The illusion of permanence is sustained by turnover, decay, and replacement, while the storm never halts. Even the brain, seat of memory and identity, is not immune. High-energy particles occasionally strike neural tissue, ionizing molecules, disturbing electrical potentials, leaving traces in the firing of neurons. Some neuroscientists have wondered whether cosmic radiation contributes, in the smallest way, to spontaneous errors in thought, to sudden lapses or unexplained flashes. While such effects are statistically minute, the possibility itself unsettles. The brain may not be entirely sealed from the random punctuation of the universe. What emerges is a picture of life inside a storm that cannot be escaped. On the ground, in the air, beneath the sea, and even underground, the flux continues. Only in carefully designed chambers of lead and steel do detectors approach silence. And even then, the quiet is never complete. For the rest of us, there is no shield, only the illusion of one. We sit in our rooms, feeling safe, unaware of the endless strikes that pass unnoticed, and yet they continue, shaping both matter and mind in ways still poorly understood. The unseen storm surrounds you now. It does not wait, does not pause, does not ask permission. It is as much a condition of life as breath or blood, and it carries with it consequences we are only beginning to comprehend. High above the surface of the Earth, beyond the thin blue veil of atmosphere, particles strike with energies so immense that human language struggles to quantify them. They arrive from every direction, accelerated across incomprehensible distances, born in events violent enough to tear apart entire stars. These are the cosmic rays, first hinted at in the balloon experiments of Victor Hess, and later measured with instruments precise enough to distinguish their traces through photographic plates, cloud chambers, and eventually sophisticated detectors buried deep underground. Their origin is not local. They come from the outer layers of the galaxy and from regions beyond, carrying with them the memory of catastrophes and transformations written into the fabric of the cosmos. A single cosmic ray can be hundreds of millions of times more energetic than the particles produced in human accelerators. The Large Hadron Collider at CERN pushes protons close to the speed of light, colliding them with a ferocity sufficient to recreate conditions a fraction of a second after the Big Bang. Yet the most powerful cosmic rays observed by detectors like the Pierre Auger Observatory in Argentina dwarf these laboratory creations. When they collide with atoms in the upper atmosphere, they unleash cascades of secondary particles, pions, muons, electrons, that rain down in vast showers across the surface of the Earth. Invisible to the naked eye, these showers can cover entire square kilometers, spreading energy that originated from a distant supernova or the jets of a black hole billions of light-years away. The realization that these high-energy visitors are striking us constantly reframes the idea of cosmic isolation. Humanity lives not under a dome, but in the crossfire of galactic debris. Every second, an atmospheric layer only a few molecules thick absorbs the blows of incoming radiation. Without it, the storm would sterilize the planet. Yet the protection is not perfect. Muons, heavy cousins of the electron created in these collisions, are capable of passing through meters of solid rock and steel. They stream into subway tunnels, research laboratories, and even the deepest mines. Sensitive detectors must account for their ever-present signatures because they interfere with the measurement of rarer, subtler phenomena. Historically, the study of cosmic rays played an essential role in shaping modern physics. Before particle accelerators existed, the universe itself provided a natural laboratory. In 1932, Carl Anderson identified the positron, the first evidence of antimatter, by studying cosmic ray tracks in a cloud chamber. Later, discoveries of the muon and the pion, both crucial to particle theory, also emerged from these investigations. In this sense, every high-energy particle striking the atmosphere carried the potential to reveal an unknown building block of reality. Cosmic rays were not merely background noise, but messengers delivering new chapters of physics. The psychological dimension of this discovery is subtle but profound. For centuries, the heavens were viewed as distant, serene, unchanging. Astronomy dealt with light, a signal that could be seen, measured, and charted. The revelation that the sky rains particles of staggering violence undermined this image. The mind is forced to reconcile two contradictory realities: the night sky as peaceful backdrop, and the same sky as a source of continuous bombardment. This tension creates a cognitive dissonance that parallels earlier shifts in human perception, such as the recognition that Earth is not the center of the universe, or that time and space are not absolute. The realization destabilizes a comfortable illusion, leaving in its place a reality that is stranger, more hostile, and yet more interconnected. Some cultures anticipated this unease in metaphorical form. Ancient myths spoke of fiery darts falling from the heavens, of weapons hurled by gods in anger. Lightning was understood as divine punishment, meteors as omens of war. While these were symbolic explanations rather than scientific truths, they reveal a persistent human intuition that the sky does not merely watch, but acts upon us. Modern particle physics replaces divine anger with astrophysical violence. Supernova shock waves, gamma-ray bursts, black hole jets. Yet the essential unease remains. Something immense and impersonal reaches us, striking indiscriminately, touching every body and every structure on Earth. The neurological consequences of exposure to high-energy particles are also being examined. Astronauts, in orbit or traveling beyond Earth's magnetosphere, report flashes of light even with eyes closed, phenomena attributed to cosmic rays interacting with the retina or visual cortex. These phosphenes, random sparks against the darkness of space, are direct evidence of particles penetrating the nervous system. While the precise biological impact of such events is still being studied, the unsettling truth is unavoidable. The brain itself can be momentarily punctuated by the universe. These encounters may have no lasting consequence, or they may accumulate subtle damage over time, adding to the uncertainty surrounding long-term space travel. Cosmic rays, though destructive at high intensities, also carry creative potential. Some researchers suggest they may have influenced early biological evolution by increasing the rate of genetic mutations. A small strike against DNA can alter a sequence, sometimes harmfully, sometimes without effect, and occasionally in a way that provides a novel advantage. If this interpretation is correct, the rain of cosmic particles across millions of years is not merely a hazard, but a driver of diversity, shaping the trajectory of life itself. In this perspective, humanity's existence is not separate from the bombardment, but entwined with it. The storm may be written into our very genes. Despite decades of research, the mystery of their origin remains unresolved in many respects. Some cosmic rays can be traced to supernova remnants, where magnetic fields accelerate protons to extreme velocities. Others appear to originate from quasars or active galactic nuclei, where supermassive black holes release energy across unimaginable scales. Yet the highest energy particles still defy explanation. No known astrophysical object has the capacity to hurl matter with such intensity. Each detection forces scientists to confront the possibility that undiscovered processes, or even unknown physics, may be at work in the fabric of the cosmos. The paradox is that we experience these events not as direct encounters, but as imperceptible intrusions passing through us silently. The vast majority of people remain unaware that their bodies are crossed daily by the byproducts of ancient explosions. But ignorance does not erase exposure. The storm continues, indifferent to awareness, shaping both matter and mind in ways we are still learning to trace. What remains unresolved is not only the origin of these cosmic visitors, but their deeper role in the ongoing interplay between the universe and the fragile life that rises within it.
Among the most elusive participants in this ceaseless bombardment are particles so insubstantial that entire planets cannot hold them back. They are called neutrinos, ghostly fragments of matter that glide through flesh, stone, and steel with scarcely a trace. Every second, billions of them pass through your body, streaming from the core of the sun, from distant galaxies, and from the radioactive decay of elements buried deep within the Earth. To the senses, they are undetectable. To instruments, they are nearly so. Yet they are real, and their existence alters the way we think about the universe. The peculiar nature of neutrinos arises from their vanishingly small probability of interaction. They carry no electric charge and possess only the faintest whisper of mass. This makes them indifferent to electromagnetic fields and largely immune to collision with ordinary matter. A beam of neutrinos could travel through a block of lead light-years thick and emerge unchanged. If matter appears solid, neutrinos remind us that solidity is an illusion. The atoms in your body are mostly empty space, and through that space streams a relentless tide that cannot be felt. Their discovery was born of a puzzle. In the 1930s, physicists studying radioactive decay noticed missing energy. When a neutron decayed into a proton and an electron, the energy carried away did not balance. Wolfgang Pauli proposed a solution. An unseen particle must also be escaping, carrying the missing energy with it. His suggestion, bold at the time, was meant to save the conservation laws of physics. It would take decades before experiments confirmed this ghost particle's existence, and even then, only with difficulty. Detectors filled with cadmium chloride or later with enormous tanks of water and cleaning fluid were required to catch the faint flashes that occur when, on rare occasions, a neutrino collides with an atomic nucleus. One of the most striking demonstrations of their abundance came with the problem known as the solar neutrino puzzle. Early detectors, such as the Homestake experiment buried deep in a South Dakota mine, counted only a fraction of the neutrinos predicted by theory. 4 years, the discrepancy troubled physicists. Was the sun weaker than models suggested? Or was something stranger happening to the neutrinos themselves? The answer, uncovered at the turn of the 21st century, was that neutrinos change identity as they travel, oscillating between different flavors: electron, muon, and tau. This phenomenon, confirmed by observatories like Super Kamiokande in Japan and the Sudbury Neutrino Observatory in Canada, revealed that neutrinos possess mass after all, though infinitesimally small. That discovery reshaped fundamental physics, forcing revisions in the Standard Model. The psychological resonance of such findings is profound. To live in a universe where even the smallest particles resist definition unsettles the human mind, which seeks categories and boundaries. Neutrinos evade capture, changing form as they move, appearing almost as tricksters within the subatomic world. Their behavior resonates with myths of shapeshifters and spirits, entities that cross thresholds without leaving a mark. Across cultures, stories describe visitors who pass unseen, altering events without being noticed. In the language of modern science, neutrinos embody a similar enigma. Present everywhere, tangible nowhere, constantly crossing the boundaries of matter without regard for walls or flesh. Detecting them requires feats of engineering that border on the surreal. Deep beneath mountains or under kilometers of ice, physicists construct chambers of unimaginable size. Superkamiokande, a cylindrical cavern filled with 50,000 tons of ultrapure water, sits beneath Mount Aikino in Japan. Its walls are lined with thousands of photomultiplier tubes, each sensitive enough to record the faintest flash of Cherenkov radiation, the bluish light produced when a neutrino collides with a water molecule. These flashes occur rarely, perhaps a handful in days of waiting, yet they testify to the passing of trillions. To see them requires patience, isolation, and a willingness to stare into silence, waiting for a sign from particles that slip through unnoticed by all else. The isolation of such experiments also reveals something about human perception. Neutrino detectors are placed deep underground not because neutrinos need shielding, they pass through everything, but because other forms of radiation must be excluded. Cosmic rays, natural radioactivity, even the decay of potassium in the rock, all produce noise that drowns the faint signal of the ghost particles. To hear the neutrino is to silence the rest of the universe. There is a strange parallel here with meditative practice, where the mind seeks stillness in order to sense what usually passes unseen. Just as monks retreat into caves to quiet the senses, physicists retreat into caverns to glimpse the fleeting passage of the invisible. The presence of neutrinos also raises unsettling questions about the boundary between inner and outer worlds. If billions cross the brain every second, how much of our neural activity is punctuated by these silent intrusions? The probabilities are small, but given enough time, a neutrino strike can split an atom in DNA, alter a signal in a neuron, or leave a scar in electronic memory. Space agencies consider such possibilities when planning long missions, for even the smallest chance becomes significant across years of exposure. What is more difficult to measure is the psychological effect of living with this awareness, the sense that one's body is never sealed, never fully separate, but always porous to the universe. In some speculative corners of neuroscience, researchers have wondered whether rare interactions could influence cognition in ways not yet understood. A particle striking the retina produces light where there was none. What might a particle striking a neuron in the hippocampus produce? Most likely, nothing measurable. Yet the possibility lingers, and with it a reminder that the boundary of the mind is not impenetrable. The thought itself carries an unease, for it implies that memory, perception, even thought are vulnerable to the same invisible flux that sculpts matter across galaxies. If neutrinos exist in such abundance, what else might flow through us unseen? Their discovery suggests that the universe still hides forms of matter that remain beyond reach, their traces faint, their presence inferred only by what seems missing. The search continues, not only for neutrinos themselves, but for what lies beyond them, in realms where even ghost particles appear substantial by comparison. The silence of underground caverns, the faint flashes in photomultiplier tubes, are fragments of a larger mystery, one that continues to press upon us with every passing second. The sun is not merely a distant sphere of fire, it is a restless engine of plasma, constantly releasing streams of charged particles into interplanetary space. This flow, known as the solar wind, pours outward in all directions, carrying with it the magnetic breath of our star. Every second, countless electrons and protons are hurled across the solar system at speeds reaching hundreds of kilometers per second, an invisible gale that sweeps past planets, moons, and spacecraft alike. Earth lies directly in its path, and yet life persists, sheltered by protective layers of atmosphere and magnetic field that were not designed but shaped by geological and cosmic accidents across billions of years. The solar wind is not uniform. It waxes and wanes with the activity of the sun, intensifying during solar flares and coronal mass ejections. During these events, loops of magnetic energy erupt from the surface of the star, releasing vast amounts of plasma. When this wave of particles reaches Earth, it interacts violently with the magnetic field, compressing it on the sunward side and stretching it into a long tail on the night side. Instruments in orbit measure the disturbance as a geomagnetic storm, while at the surface, Power grids may flicker, radio signals may falter, and navigation systems can become unreliable. These disruptions remind us that civilization depends not only on technology, but also on the stability of an invisible barrier between Earth and its parent star. The aurora borealis and aurora australis provide a visible trace of these otherwise imperceptible events. High above the polar regions, solar particles spiral along magnetic field lines and collide with atoms in the upper atmosphere. Oxygen emits green and red light, while nitrogen produces purple and blue hues. The shimmering curtains of color reveal that the sky itself is alive with motion. To those who witness them, the auroras appear mystical, yet behind the spectacle lies a simple fact. They are visible scars of the storm, the point where cosmic weather collides with terrestrial atmosphere. What most observers do not consider is that these same collisions occur across the entire planet, though invisible in regions away from the poles. Even when the night is clear and calm, the unseen strikes continue, refracted only occasionally into visible light. Human psychology often treats the Earth as stable and unchanging, a stage upon which external forces play only at the edges. The reality, uncovered by space science, is that the planet is immersed in a shifting, turbulent environment that can be disturbed at any moment by activity from the Sun. The nervous system evolved under these conditions, though without conscious awareness of them. There is no sensory receptor for geomagnetic disturbance, no instinctive perception of solar storms, yet some studies have suggested subtle correlations between geomagnetic activity and fluctuations in human physiology. Reports of changes in heart rate variability, mood alterations, and even variations in the incidence of certain health events during geomagnetic storms have led researchers to speculate that our bodies may register the storm in ways we do not consciously feel. The mechanism remains uncertain, but the possibility hints at a deeper coupling between biology and space rather than previously considered. Animals, more attuned to the geomagnetic field, offer additional evidence of this hidden connection. Migratory birds, sea turtles, and even certain species of insects navigate using geomagnetic cues, a sensitivity so refined that shifts in the field caused by solar activity may disrupt their orientation. In laboratory experiments, magnetoreception has been traced to proteins called cryptochromes, sensitive to quantum effects within cells that respond to changes in magnetic fields. If such delicate mechanisms can exist in non-human species, the question lingers whether subtler forms of geomagnetic sensitivity might persist in humans, long buried by cultural evolution but still flickering at the edge of perception. The shield provided by Earth's magnetosphere is both vital and imperfect. It diverts the majority of solar particles, funneling them harmlessly around the planet. Yet it is not absolute. Some particles penetrate into the atmosphere, especially during intense storms, and can interfere with satellites, degrade electronics, or damage solar panels. Astronauts outside low Earth orbit face far greater risks, exposed to particle radiation that can damage DNA, increase cancer risk, and impair cognitive function. For those who dream of interplanetary travel, the solar wind is not an abstraction but a barrier that must be overcome, a constant hazard pressing against the boundaries of fragile human flesh. The thought that human consciousness evolved under the protection of this magnetic barrier carries its own implications. Without the magnetosphere, Earth would resemble Mars, stripped of atmosphere by the unrelenting solar wind. There would be no oceans, no forests, no breath. In this sense, every living thought has occurred within a protective cocoon, a shield we cannot perceive but that makes all perception possible. The storm rages outside, yet awareness blooms inside. This arrangement is precarious, contingent, and subject to change, for Earth's magnetic field is not constant. It drifts, weakens, and occasionally reverses polarity over geological timescales. During periods of transition, the shield may falter, allowing more solar radiation to reach the surface. What such episodes meant for ancient life remains a matter of speculation, but the geological record hints at correlations between magnetic reversals and shifts in biological evolution. If the shield were to weaken dramatically in the future, modern life would confront vulnerabilities unimaginable to earlier generations. Power grids could collapse under geomagnetically induced currents, communication networks could falter, and satellites could be rendered inoperable. Beyond the technological risks lies the biological question. What does sustained exposure to elevated levels of solar particles mean for the nervous system, for cellular integrity, for the stability of the mind? Researchers have begun to explore these uncertainties, but the answers remain incomplete. The protective cocoon holds, yet it is not invulnerable. The sun continues to send its breath across space, relentless and unending, shaping every moment of terrestrial life in ways most never perceive. The magnetic shield quivers under the pressure, bending but not breaking, holding back the gale that seeks entry. The storm outside is constant, and the barrier that protects us is neither absolute nor eternal. What lingers in uncertainty is how much of that storm already seeps through, influencing life in ways we have only begun to detect. Beneath our feet, another source of invisible particles is constantly at work. The Earth itself is not inert but alive with decay, the slow unraveling of unstable atoms forged in ancient stellar furnaces. Uranium, thorium, and potassium-40, locked within rock since the planet's formation, undergo radioactive transformation, releasing alpha particles, beta particles, and gamma rays that seep outward into soil, water, and air. Every cubic meter of the ground beneath a city holds atoms on the verge of disintegration, atoms that cast off fragments at random, striking the bodies that walk above without recognition. This hidden release is part of the planet's metabolism, a process that has continued unbroken for billions of years, shaping geology and quietly influencing the conditions of life. One of the most insidious examples is radon gas. Produced by the decay of uranium in rock, radon seeps upward through cracks in the earth, accumulating in basements and enclosed spaces. Invisible, odorless, and tasteless, it can reach concentrations that pose significant risks to human health. When inhaled, radon decay products attach to the lining of the lungs, where their radiation can damage DNA and increase the likelihood of cancer. Epidemiological studies in mining communities and later in ordinary homes revealed radon as the second leading cause of lung cancer after tobacco. The unsettling truth is that danger does not always come from external assaults, but from the ground itself, rising silently into the air we breathe. Beyond radon, the crust continuously emits gamma rays, a background field of radiation detectable with even modest instruments. Sensitive detectors can measure its fluctuations from region to region, revealing the distribution of radioactive elements embedded in stone. This radiation penetrates walls and flesh alike, indifferent to barriers. People often imagine radiation as an artifact of technology, associated with nuclear reactors or medical scans, yet it has always been present, saturating the environment long before human industry. What technology added was not radiation itself, but the recognition and amplification of forces already in play. Even the human body is not exempt as a source. Potassium-40, a naturally radioactive isotope, is present in every person. Each second, thousands of tiny decays occur within bones, muscles, and tissues, sending particles outward into surrounding cells. These events rarely cause damage, for biology has evolved mechanisms to repair or tolerate them, but the awareness that one's body is a participant in the same invisible storm adds a layer of unease. The distinction between self and environment blurs further when one realizes that radiation does not only pass through the body, but is emitted by it. This awareness has profound psychological implications. The human mind tends to construct boundaries between inside and outside, safe and unsafe, natural and artificial. The recognition that the Earth itself releases invisible fragments that penetrate those boundaries undermines this architecture of reassurance. It destabilizes the notion of home as sanctuary. The ground beneath the floorboards, the air circulating in a closed room, the very body lying at rest, all contribute to a constant flow of radiation that the senses cannot register. Safety becomes a relative condition, contingent not on absence of exposure but on thresholds of tolerance. Yet biology has always been immersed in this environment. Radioactive decay contributes to the heat of Earth's interior, driving tectonic activity and volcanic eruptions. Without it, plate tectonics might falter, and the cycle of continents and oceans would alter beyond recognition. On the molecular scale, radiation occasionally breaks chemical bonds in DNA, introducing mutations. While most mutations are harmful or neutral, some may provide rare advantages, becoming raw material for evolution. In this sense, radioactive decay is not simply a threat, but also a hidden architect of diversity. The paradox unsettles. The same invisible strikes that can damage cells and shorten lives have also, over geological timescales, seeded variation that made life's complexity possible. Cultures across history, lacking the language of physics, often interpreted the Earth's emanations in mystical terms. Sacred caves, deep fissures in the ground, or vapors rising from the Earth were considered entrances to other realms. The oracle at Delphi, for example, sat above fissures where gases emerged, believed to carry divine inspiration. While not radon specifically, the belief that the Earth releases invisible forces shaping mind and fate finds uncanny resonance with what science later uncovered. Invisible vapors, silent currents, unseen powers. The mythic imagination sensed what instruments would later quantify. The presence of natural radiation also complicates modern attempts at absolute purity. Laboratories constructing detectors for rare particles must descend into deep mines not only to escape cosmic rays, but also to minimize the noise from surrounding rock. Even then, shielding and purification cannot erase the fact that decay is inherent to matter itself. Instruments record constant flickers, signals that remind researchers the environment can never be entirely silenced. What they seek to hear is buried beneath the whisper of the Earth's own emissions, a reminder that even in controlled conditions, the background is never absent. The unsettling thought emerges that silence, in the absolute sense, does not exist on this planet. Every environment is filled with the subtle crackle of decays, the passing of particles, the shifting of atoms from unstable to stable states. If one could translate these events into sound, the world would be alive with static, a constant hiss underlying every moment. What the senses cannot hear, the body nonetheless absorbs. To live on Earth is to reside in a chamber where decay is perpetual, where the materials of mountains and soil are never entirely still but continuously transmuting. This ceaseless activity hints at deeper uncertainties. If the ground beneath us is a source of radiation, then the notion of stability is an illusion. What feels solid is not unchanging but quietly transforming, grain by grain, atom by atom. The consequences of this transformation are not yet fully mapped. Questions linger about how fluctuations in natural background radiation influence long-term health, how variations across geography shape populations differently, and how exposure accumulates across a lifetime. Each breath carries not only oxygen but also traces of the Earth's silent decay. What this continuous exchange means for life at the edge of stability remains an open condition, unsettled and unresolved. Radiation does not act only as a hazard. It also serves as an engine of transformation within biology. The genome of every living organism is a fragile ledger, constantly copied, occasionally altered, and always exposed to the possibility of disruption. Invisible particles passing through DNA can cleave its strands or change its base pairs, leaving behind errors. Most of these errors are either repaired or rendered inconsequential, yet across evolutionary timescales, the accumulation of such changes produces diversity. The hidden storm of particles is not separate from life's history, but woven into its very fabric, influencing the trajectory of species in ways subtle yet profound. The evidence for this influence is found in the patterns of mutation. Cosmic rays, in particular, are capable of producing unique signatures in DNA, distinct from those caused by ordinary chemical reactions. Experiments on bacteria exposed to increased levels of radiation demonstrate accelerated mutation rates, producing populations with new traits within generations. Similar processes occur in multicellular organisms, though stretched across longer spans. The persistence of life, despite continuous bombardment, depends not only on resilience but on the fact that some mutations confer advantages: resistance to disease, adaptation to climate, or the emergence of entirely novel functions. What appears destructive on the scale of an individual becomes creative on the scale of populations. This interplay has shaped not only the past but also the present. The human genome contains remnants of ancient viral insertions, rearrangements, and duplications, many of which were likely influenced or accelerated by radiation exposure. Some of these once random disruptions later became essential to function. The gene syncytin, crucial for the formation of the placenta, derives from a viral sequence embedded in human DNA millions of years ago. Radiation may have aided in the integration of such elements, altering the course of reproduction itself. In this sense, the silent strikes of particles are not merely background noise but hidden architects of physiology. The relationship between radiation and biology is double-edged. While mutation provides raw material for evolution, excessive exposure leads to damage beyond repair. Studies on survivors of nuclear accidents and atomic bombings revealed increased cancer rates, underscoring the destructive capacity of radiation when thresholds are exceeded. Yet even these tragedies reveal a paradox. The human species continues, and descendants of exposed populations do not carry insurmountable genetic burdens. Life adapts not by avoidance of exposure, for exposure cannot be avoided, but by developing layered systems of repair, redundancy, and selection that allow survival within a storm that never ceases. Psychologically, this perspective forces a shift in how life is understood. The prevailing view often treats radiation as an intrusion, something external imposed upon the body. In reality, it is an intrinsic condition of existence, one that has guided the branching paths of evolution as much as natural selection or environmental change. The nervous system, which perceives and interprets the world, has itself been sculpted in part by this invisible influence. Every memory, every thought, every sensation is carried in neurons whose lineages were molded under the pressure of cosmic and terrestrial radiation. The storm is not only outside us, but encoded within us. Legends and myths echo this entanglement in symbolic form. Many cultures describe heroes transformed by exposure to divine fire, struck by lightning, or touched by celestial sparks. These narratives of metamorphosis mirror the biological reality that energy from beyond Earth can alter flesh at its deepest levels. What myth called divine punishment or blessing, biology recognizes as mutation, an unpredictable event that can destroy or create in equal measure. The resemblance is not literal but thematic. Humanity has long intuited that forces from the sky shape life in hidden ways. Contemporary science continues to probe this influence with controlled experiments. Plant seeds exposed to cosmic radiation aboard satellites exhibit altered growth patterns when returned to Earth. Some strains develop advantageous traits, leading agricultural researchers to explore space as a breeding ground for new varieties. What occurs spontaneously in the upper atmosphere is harnessed deliberately in orbit, a conscious use of the same forces that have operated unnoticed for ages. This practice underscores how intimately life and radiation are entwined. What once seemed a hazard alone can become a tool of creation when understood. The unresolved question is how far this influence extends into the future. As climate shifts and ecosystems strain, radiation remains a constant background, capable of producing genetic novelties that may help species adapt. Yet it may also contribute to fragility, overwhelming repair mechanisms and leading to decline. The balance between creation and destruction, between mutation that enriches and mutation that corrodes, is delicate. The trajectory of life hinges on this balance, sustained by a storm of particles that respects no boundary. Within this context, human technology introduces another layer of complexity. Medical imaging, cancer treatments, and industrial processes all employ radiation intentionally, adding artificial exposures to the natural flux. Each intervention intersects with the long-standing dialogue between radiation and biology. Whether these practices accelerate adaptation or heighten vulnerability remains a matter of study, but they demonstrate that humanity now participates knowingly in the manipulation of forces once regarded as untouchable. The thought lingers that every heartbeat occurs under conditions shaped by particles that began their journey in distant stars, by isotopes buried deep in stone, and by radiation that has been a companion to life from its earliest forms. The genetic code, fragile yet enduring, continues to absorb these influences, rewriting itself in ways both predictable and unforeseen. What remains uncertain is how many of these invisible strikes will ripple outward into the future, altering not only individual lives but the course of entire species. Beyond the known sources of radiation and particle flux lies an even greater mystery, one that unsettles the foundations of physics itself. Astronomical measurements reveal that the matter we see, stars, planets, gas, dust, even the countless galaxies mapped across the sky, accounts for only a fraction of the universe. The rest is hidden. The gravitational pull of galaxies cannot be explained by visible matter alone. Stars orbit their centers too quickly. Clusters of galaxies cling together more tightly than their luminous contents allow. Something unseen must provide the missing mass. This hidden component, termed dark matter, outweighs ordinary matter by a factor of 5 to 1, yet no instrument has captured it directly. If it exists in particle form, then Earth, and every human body, is immersed in a sea of invisible entities flowing constantly through flesh and stone without recognition. The candidates for dark matter are speculative but grounded in theoretical frameworks. One class is known as WIMPs, weakly interacting massive particles. These hypothetical particles would have mass comparable to or greater than that of a proton, but would interact so rarely with ordinary matter that they pass through planets without scattering. If WIMPs exist, then trillions traverse each person every second, ghostly presences that carry mass but leave almost no trace. Another possibility is axions, particles predicted to solve theoretical problems in quantum chromodynamics. Axions would be extraordinarily light but present in such abundance that together they could account for the missing mass. A further candidate is the sterile neutrino, a cousin to the known neutrinos but even more elusive, interacting only through gravity. Each possibility points to a hidden ocean of matter flowing unseen, pressing through our bodies in silence. The implications extend beyond physics into psychology and philosophy. For centuries, matter was defined by its tangibility, what can be touched, measured, or weighed. Dark matter overturns this intuition, suggesting that most of reality is untouchable. The mind, evolved to track visible and tactile objects, struggles with the notion that the majority of matter cannot be seen or felt. This cognitive gap mirrors earlier challenges, the discovery that Earth moves through space, or that time bends with gravity. But dark matter is more intimate. If it surrounds us constantly, flowing through bones and organs, then the self exists within a medium that cannot be sensed. Human perception, which defines reality by what can be experienced, becomes inadequate, and with that inadequacy comes unease. Efforts to detect dark matter reflect the extremity of the challenge. Experiments such as the Xenon detector in Italy or the LUX Zeppelin experiment in the United States place tons of liquid xenon in underground chambers, shielded from cosmic rays and natural radioactivity. The goal is to observe the faintest flicker of light when a dark matter particle collides with an atomic nucleus. Decades of attempts have produced no definitive detection, only constraints on possible properties. Yet the pursuit continues, driven by the recognition that the stakes are immense. To find dark matter would be to uncover the majority of the universe's mass, a discovery that would alter not only cosmology, but the understanding of what flows invisibly through every human being. In the absence of detection, the imagination turns toward analogies. Just as fish are unaware of the water they swim in, humanity may be blind to the medium in which it exists. Ancient traditions often spoke of subtle substances, ether, spirit, quintessence, filling the cosmos. While not equivalent to dark matter, these concepts capture a persistent intuition that emptiness is never truly empty. Science strips away metaphor to reveal measurable forces, yet the resonance remains. The thought that we are penetrated and surrounded by entities we cannot sense aligns with long-standing cultural narratives of hidden currents and unseen presences. If dark matter does interact, however faintly, with ordinary matter, then its passage through biological tissue may not be entirely without consequence. Though probabilities are low, across the vast number of particles and the span of evolutionary time, even rare collisions could leave imprints. A scattered atom in DNA, a displaced proton in a neural membrane, a cascade in the delicate machinery of a cell. Such events would be indistinguishable from those caused by more familiar sources of radiation. Whether they have played a role in shaping biological history remains uncertain, but the possibility cannot be dismissed outright. The unsettling implication is that life may be molded not only by forces we know, but by a background that remains hidden, a sculptor whose hand is unseen. Astronomical observations deepen the enigma. Gravitational lensing, the bending of light around massive objects, reveals halos of dark matter surrounding galaxies, invisible scaffolds that shape the structure of the cosmos. The distribution of this hidden matter dictates where galaxies form, how they cluster, and how the universe evolves on the largest scales. If such scaffolds also thread through the Earth and the human body, then existence itself is framed by invisible architecture. What we perceive as empty space may be a crowded domain, filled with particles that carry weight but evade the senses. The intimacy of this idea unsettles the boundary between the known and the unknown, between what science measures and what slips perpetually out of reach. This confrontation with the unseen does more than challenge physics. It tests the human conception of reality. If most of matter is dark, then the visible world is a fragment, an island within a vast ocean. The mind, accustomed to anchoring truth in perception, must reckon with the knowledge that perception captures only a minority of existence. The silence of detectors, the absence of signals, is itself a message that reality may be stranger and more abundant than imagination has yet conceived. The question that lingers is not only what dark matter is, but what its ceaseless flow through us means. If trillions of invisible particles pass through each body every second, then life is not merely immersed in the known storms of cosmic rays, neutrinos, and radioactive decay, but in something greater still, a background that may remain undetectable for generations. Whether this background is inert, or whether it leaves subtle fingerprints on the story of life, remains unresolved. The awareness of this uncertainty expands the horizon of unease, pressing thought toward the possibility that the most substantial part of the universe has yet to reveal its face. To glimpse what moves invisibly through the world, humanity has built machines of extraordinary scale and sensitivity. Ordinary instruments cannot register the passage of neutrinos, muons, or hypothetical dark matter particles. Their traces are too faint, their interactions too rare, their signals drowned in the constant background of terrestrial radiation. The pursuit of these elusive entities has led scientists to excavate caverns beneath mountains, drill shafts deep into Antarctic ice, and fill vast tanks with purified liquids capable of registering the faintest flash of light. Each of these structures functions not as a traditional telescope, but as a kind of inverted eye, one that sees not by collecting visible light, but by waiting for the whisper of the invisible. The logic of these observatories is paradoxical. To detect what passes through everything, one must seek silence. Cosmic rays rain down constantly, generating showers of secondary particles that overwhelm any delicate measurement. To escape this storm, detectors are buried beneath kilometers of rock, placed under oceans, or embedded in polar ice sheets. Shielded from most interference, they can then listen for the rare, improbable interaction between an unseen particle and ordinary matter. When such an encounter occurs, the signature is often indirect: a photon of Cherenkov radiation, a faint pulse in a photomultiplier tube, or a subtle recoil in a liquid crystal lattice. One of the most striking examples is the Ice Cube Neutrino Observatory in Antarctica. Beneath the frozen surface, scientists have lowered more than 5,000 light sensors into a cubic kilometer of ice. When a high-energy neutrino collides with a nucleus in the ice, it produces a charged particle moving faster than light travels through that medium. This generates a cone of blue Cherenkov light, which spreads through the ice and is recorded by the sensors. From the geometry of these flashes, researchers reconstruct the path of the neutrino, tracing it back across space to its source. With this method, IceCube has linked some detected neutrinos to distant blazars, galaxies with supermassive black holes that launch jets of particles across the cosmos. The observatory transforms the frozen Antarctic plateau into an enormous, transparent eye staring into the invisible. Elsewhere, other detectors seek different signatures. The Gran Sasso Laboratory in Italy houses experiments like Xenon-NT, which uses several tons of liquid xenon to search for faint nuclear recoils caused by potential dark matter interactions. The tank is encased in layers of shielding, submerged in water, and buried beneath a mountain to minimize interference. For years, researchers have monitored the liquid xenon for the faintest glimmers of light that might signal the passage of a particle beyond the standard model. Each false signal, from natural radioactivity, cosmic rays, or instrumental noise, must be meticulously distinguished from what might be the first evidence of the universe's hidden mass. The tension in such laboratories is palpable, for the difference between silence and discovery can hinge on a single photon. Even earlier detectors, though cruder by modern standards, captured the imagination. In the Homestake mine of South Dakota, a massive tank filled with cleaning fluid was monitored for traces of chlorine atoms transmuted into argon by solar neutrinos. Over decades, only a few dozen such atoms were collected, yet from these rare conversions emerged the realization that neutrinos oscillate between identities. The patience required for such work is immense. Years of waiting yield only handfuls of data points, yet each point carries weight sufficient to reshape theories of physics. The pursuit of the invisible requires endurance as much as ingenuity, a willingness to listen to silence in the hope that the silence will one day be interrupted. The very act of constructing such detectors alters the way we think about knowledge. Unlike a telescope, which captures a flood of photons in every glance, these instruments thrive on absence, on rare interruptions in otherwise featureless noise. This inversion resonates with certain psychological and cultural practices, in which silence and emptiness are seen as conditions for revelation. Meditation, fasting, or sensory deprivation seek truth not in abundance but in scarcity. Likewise, the physics of the invisible requires stripping away everything extraneous until only the faintest residue remains. The parallel is striking. The scientist and the ascetic both withdraw into depth and silence, seeking signals that cannot be heard amid the clamor of ordinary existence. What emerges from these efforts is not only data, but a new sense of scale. A single detected neutrino may correspond to billions that passed through unnoticed. A rare recoil in a xenon atom represents countless missed interactions. The asymmetry between what is seen and what is unseen grows daunting. Human instruments register only fragments, yet those fragments hint at forces vast enough to shape galaxies. The awareness that most of the universe passes through unrecorded imposes a humility upon knowledge. What is detected is never the whole, only a sliver of the storm. Yet this sliver carries implications that reverberate far beyond physics. If underground caverns and frozen deserts can serve as portals to hidden layers of reality, then the boundary between the visible and invisible is more porous than once assumed. Each faint flash of Cherenkov light or flicker in a detector reveals that the storm is not an abstraction but a measurable, physical presence. To know that the invisible has been glimpsed, however briefly, alters perception. The mind begins to imagine what other currents may be passing undetected, what other forces remain beyond reach, and whether the storm that surrounds us is only the beginning of a deeper, uncharted sea. Invisible particles, though often harmless at ordinary levels, carry within them the capacity to disrupt the integrity of living systems when exposure exceeds biological thresholds. Radiation, whether from cosmic rays, solar storms, or terrestrial decay, delivers energy directly into the delicate machinery of cells. This energy can ionize molecules, fracture DNA, or trigger cascades of chemical reactions that overwhelm the body's repair mechanisms. The effects accumulate slowly, hidden at first, then manifest in illnesses that alter the trajectory of life. The paradox is that humanity exists in constant contact with these forces, yet has only partially mapped their dangers. The medical understanding of radiation risk grew out of tragedy. Early radiologists, experimenting with X-rays in the late 19th century, exposed themselves without caution. Burns, lesions, and cancers soon followed, providing grim evidence of the body's vulnerability. Later, the survivors of Hiroshima and Nagasaki revealed long-term consequences, elevated cancer rates, genetic damage, and neurological effects. These outcomes became the foundation of modern radiobiology, where dose, duration, and tissue sensitivity are meticulously charted. Yet the complexity of biological response resists simplification. Low doses may stimulate repair mechanisms, while intermediate doses produce damage, and higher exposures overwhelm. The spectrum of outcomes depends on subtle balances within cells, balances that are still imperfectly understood. For astronauts, the danger is not abstract but immediate. Outside Earth's protective magnetosphere, cosmic radiation and solar particles bombard spacecraft with intensity. Shielding reduces exposure but cannot erase it, as high-energy particles penetrate materials and create secondary radiation inside. Long-duration missions to the Moon or Mars will subject the human body to doses that may impair cognition, accelerate cardiovascular disease, and elevate cancer risk. Studies using particle accelerators to simulate cosmic radiation on animals reveal persistent changes in neural function, hinting at memory loss and reduced adaptability. Space agencies struggle to calculate acceptable risks, for the numbers carry not only statistical weight but existential consequence. The cost of miscalculation may be measured in the viability of future exploration itself. On Earth, natural background radiation also carries uncertainty. Epidemiological studies in regions of elevated natural radiation, such as Kerala in India or Ramsar in Iran, show no consistent patterns of increased illness, raising questions about whether low-level exposure may be tolerated or even beneficial. The concept of radiation hormesis, that small doses may stimulate protective mechanisms, remains controversial, its evidence fragmentary, its implications profound. If true, it would mean the boundary between danger and adaptation is less rigid than often portrayed. Yet the ambiguity persists, leaving public health policy suspended between caution and recognition of uncertainty. Beyond the physical dangers lies the psychological dimension. Radiation is invisible, intangible, and imperceptible without instruments. This invisibility breeds anxiety, for the mind struggles with threats it cannot sense. After nuclear accidents such as Chernobyl or Fukushima, many of the most severe health effects arose not from radiation itself, but from fear, displacement, and social upheaval. Studies documented elevated rates of depression, anxiety, and post-traumatic stress among affected populations, even when measured doses were below thresholds of physical harm. The danger is not merely the particle, but the perception of it, and perception spreads contagiously through rumor, media, and memory. The nocebo effect, where belief in harm produces real symptoms, plays a powerful role in shaping collective response. The resilience of life complicates the picture further. Bacteria such as Deinococcus radiodurans can withstand radiation doses thousands of times greater than lethal levels for humans, repairing DNA with astonishing efficiency. Tardigrades, the microscopic water bears, endure both cosmic radiation and vacuum exposure, surviving conditions lethal to most organisms. These examples reveal that biology is not uniformly fragile. Evolution has produced strategies to endure extremes, strategies that may one day inspire biomedical approaches to protect human tissue. The fact that such resilience exists in simple organisms raises the question of whether more complex life has latent capacities for adaptation that remain unexpressed. The uncertainty surrounding long-term exposure highlights gaps in scientific knowledge. Decades of study have mapped the effects of high doses, but the subtle impacts of continuous low-level radiation remain elusive. Do they accumulate silently in tissues, contributing to aging and disease? Do repair systems cancel them, leaving little trace? Or do they produce hidden shifts that alter physiology in ways not yet measured? Instruments grow more sensitive, yet the complexity of living systems resists straightforward answers. Every dataset carries ambiguity, every conclusion opens to counterexamples, and the mind is left to grapple with a danger that is neither entirely definable nor entirely dismissible. These questions become sharper as technology entwines with biology. Nuclear medicine relies on radiation to diagnose and treat disease, delivering targeted doses to destroy tumors while sparing healthy tissue. The success of such treatments illustrates that radiation is not solely destructive but can be harnessed with precision. Yet even here, uncertainty lingers. What are the long-term effects on tissues outside the target, and how do repeated exposures accumulate across decades of life? Medicine walks a line between cure and harm, guided by probabilities rather than certainties. The body, exposed for millennia to natural radiation, now receives artificial doses layered atop the storm it has always endured. The danger, the resilience, and the mystery coexist uneasily. Every particle carries the potential to harm, but also the possibility of irrelevance. Biology continues, adapting, repairing, and sometimes succumbing, while the storm persists without pause. The boundaries between safe and unsafe, tolerable and lethal, protective and destructive, remain blurred. What unsettles most is the realization that humanity inhabits an environment where exposure is not optional. The storm cannot be switched off, nor can the body step outside it. What remains unresolved is how deeply its consequences reach, how much of life is shaped by forces that strike unseen, and whether the future holds stability or deeper vulnerability beneath their constant touch. Humans inhabit a world that never ceases to be penetrated by invisible storms. The bombardment is constant, impartial, and indifferent to awareness. Every living cell, every stone, every drop of water is crossed by particles that began their journeys in cataclysms far beyond imagination or rose quietly from the decay of matter beneath the soil. To exist is not to stand apart from this flux, but to live within it, shaped by it, and altered by it in ways both obvious and hidden. What appears to be stillness is only a fragile surface, beneath which a vast interplay of unseen currents continues without pause. The mind, constructed to orient itself toward tangible objects, struggles to reconcile with this reality. Human perception is tuned to light and sound, to warmth and touch, yet the true environment extends beyond the reach of the senses. Every second, radiation passes through flesh and bone, while dark matter, if it exists as theory suggests, flows invisibly through bodies, continents, and oceans. The nervous system registers none of this, yet to deny its presence would be to deny the fabric of physics itself. This disjunction between perception and reality breeds unease, for it means that much of existence occurs beyond awareness, in domains where the body is porous and the mind blind. The psychological implications of this are rarely addressed in everyday life. Most people move through the world with the implicit assumption of solidity. Walls protect, roofs shelter, clothing insulates. Yet the invisible storm disregards all barriers. Lead may slow some particles, but most continue through as though no obstacle were present. The knowledge of this undermines the instinctive architecture of safety. It suggests that protection is partial, conditional, and perhaps illusory. The very notion of security must be reframed, not as absence of exposure, but as endurance within unavoidable exposure. To live in such a state is not unique to humans. Every organism that has ever drawn breath has done so under the same conditions. From the first replicating molecules in ancient seas to modern civilizations encased in technology, life has persisted inside the storm. Adaptation, mutation, and repair have been sculpted not in isolation but under ceaseless bombardment. Evolution itself can be seen as a negotiation with invisibility, a balance between vulnerability and resilience in the face of constant intrusion. The blueprint of life bears the scars of this negotiation, written across genomes as silent records of encounters with forces that left no memory in consciousness but altered the path of survival. Yet survival is not the only question. The storm carries implications for identity, for the very sense of what it means to be human. If trillions of particles cross each body every second, then the boundary between self and world dissolves. The individual is not isolated but interpenetrated by the universe, a temporary arrangement of matter sustained within a flow that knows no boundary. Schrödinger's notion of life as an eddy in a stream of particles becomes less a metaphor and more a direct description. The body is a process, not a container. To recognize this is to confront a vision of the self that is fluid, permeable, and contingent. Cultural echoes of this condition are found across traditions. Ancient texts spoke of subtle winds, breaths, or currents moving through the body, linking the individual to the cosmos. Whether called prana, chi, or pneuma, these concepts attempted to articulate the intuition that life is not sealed but suffused with unseen flows. Science strips away the symbolic language and replaces it with neutrinos, cosmic rays, and hypothetical dark matter, yet the essence remains. Existence is inseparable from what moves invisibly through it. The persistence of such parallels across cultures suggests that humans, even without instruments, sense that the world is not as still or self-contained as it appears. The confrontation with this reality invites both dread and awe. Dread arises from the recognition of vulnerability, the body struck, the genome altered, the nervous system permeated by forces beyond control, or emerges from the realization of connection, that each person stands within a web of cosmic events, touched by remnants of stars, brushed by particles that have traveled billions of years. To carry within oneself traces of distant galaxies and ancient rocks is to exist not as a separate being but as a node in a vast continuum. The invisible storm is not only a danger but also a reminder that life is entangled with the universe at every level. Yet the storm remains poorly mapped. Instruments detect fragments, laboratories construct models, and theories speculate about what cannot yet be observed. The gap between what is known and what remains hidden is immense. Dark matter may be flowing through the body this very moment, unrecognized, its influence undetected. Particles beyond current classification may exist, striking with energies that exceed comprehension. The absence of certainty leaves open the unsettling possibility that life is shaped by forces still unnamed, that the storm is richer and more complex than even the most sensitive detectors reveal. The awareness of this unresolved condition presses thought forward. If the universe is ceaselessly striking us with particles both known and unknown, then the map of existence is incomplete. Every breath, every moment, unfolds within a medium that is only partially understood. The storm surrounds, penetrates, and shapes, yet remains elusive to the senses. What other currents may still be passing through, unmeasured and unnamed, lingers as an unanswered question, carrying with it the weight of all that remains unseen.